This is a video for Edexcel Further Pure 1, Further Vector Geometry Section 2.4, using the cross product to find shortest distance between skew lines. Well, the idea of skew lines has already been met, and in fact you have a method for finding the shortest distance between them. This is an alternative which uses the cross product to help. So remember then, the distance between two skew lines will be the length of the line joining R1 and R2, which is perpendicular to both of R1 and R2, as indicated here by XY. Now we can find a vector in that direction by looking at the cross product of D1 and D2. So D1 cross D2 is a vector in the direction of XY. But then if we divide that by the length of D1 and D2, so we get this expression here, that is going to be a unit vector in that direction, n hat. Now all we need to do to find the length of XY is to find a line which we know, which joins P and Q, and project it onto the direction n hat. In other words, we need to find PQ dot n hat, where P and Q is a line that we know joining the two lines R1 and R2. But we can get that by using A and B. So in fact PQ could be the vector which is B minus A. And so we get that B minus A dot n hat will give us the length of the line XY. So PQ dot n hat is the same as B minus A dot n hat. Now if we substitute our expression for n hat that we had, we get that B minus A dot n hat came from the cross product of D1 with D2, and to make it unit length we divide it by the length of D1 cross D2. Now this has got to be a positive value, so if we take the modulus of that, we will get the distance between the skew lines, in other words the length of XY. Now I want to emphasize that it's this method rather than the actual formula at the end which is important. So what we did, we looked at the direction vectors of the two lines D1 and D2. Their cross product D1 cross D2 gave us the direction of the line XY, and hence a unit vector was given by that cross product divided by its length. Once we've done that, a known line joining R1 and R2 projected onto that vector n hat gives us the length that we require. So it's the method which is important, and in A-level questions you will be led usually stage by stage through this method, as in the example which follows. So here we're given the position vectors of 3 points A, B and C. So this is A, B and C. And we're first of all asked to find the vector P, which is AB cross OC. So what we're going to do is to take AB and OC and form the cross product of those two vectors. Now that of course is going to be a vector which is in the direction of the perpendicular to both of AB and OC. So P will be in this direction. We're then going to calculate AC dot P. Now AC is just a line which joins the two lines in question, and so that dot product is going to give us the projection of AC onto the P. The question then says find the shortest distance between the line containing AB and OC. So all we need to do now is to realize that we haven't used a unit vector, we've used P, so we need to divide by the length of P to give us the required distance. So let's look at it in a little bit more detail. Firstly, we want to find AB cross OC. Well, OC is just the vector from O to C, so that will be equal to the position vector of C, so that is J plus K. AB needs a little bit more work. That's going to be position vector B minus A, and that is I plus 2J minus K, and then subtract from that A, which is 2I plus 3J, and that gives us negative I minus J minus K. So P, we're told, is going to be AB crossed with OC. So I can do that using determinant method. So that will be I, J, K, and then putting in the components for AB. They are negative 1, negative 1, negative 1. And for OC, they are 0, 1, 1. And when you calculate that, you will get J minus, J minus K. So just check through that and make sure you're happy with what we've done so far. The next part of the question asks for AC dot P. Well, P is equal to J minus K, as we just found. AC is going to be vector C minus A, and that is going to be equal to J plus K minus 2I plus 3J. So that is minus 2I minus 2J plus K. And what we want to do now is to form the dot product of that with P. So AC dotted with P, I'm going to use column vectors, be negative 2, negative 2, 1 for AC, and for P it's 0, 1, negative 1. So we calculate that and we get negative 3. Again, just look through that, make sure you're happy with the processes there. Now the final part of the question asks us to use what we've done so far, hence find the shortest distance between the line containing AB and OC. So before I do that, just a recap of what we've done. We found the line AB and the line OC. And the cross product. So the cross product gave us a vector in the direction joining those two lines. We then found a line joining 2 points on the lines, so the vector AC, and we formed the dot product, so we projected that onto the length, onto the vector P. So the only thing we haven't done is used a unit vector in this direction, P hat, rather than P. So what we need to do is to divide by the length of P. So we can say that the length of P is equal to the square root of 1 squared plus negative 1 squared, which is root 2. And hence the distance that we require will be the modulus of, because we need a positive value, AC dotted with P divided by the modulus of P. So that's going to be equal to the modulus of negative 3 over root 2. In other words, it's 3 over root 2, or 3 root 2 over 2. And there again we have the final answer written out neatly. Take a little bit of time, recap those three paths. So in essence what we did was worked through the required stages to produce the formula that we did at the beginning of the video. And questions at A level are usually going to do this. There may be little bits that are missing and you have to remember the process yourself, but in general you'll be led through to a situation where it becomes quite straightforward to work out the shortest distance in this way. Well, that's the end of this particular video, and indeed the end of the series of videos for further vector geometry.